So welcome everybody. We are glad you joined our webinar today. So webinars give us the possibility to exchange knowledge more easily without traveling. So we welcome guests today from all over Europe. And in the meantime, we are used to deal with online meetings. So please be aware that we are recording this webinar, and please use the chat. And use the microphone and the video only when directly questioning our speakers. So, first, I want to introduce Natureplus. For all of you, you're not familiar with our work, so I just want. So, Natureplus Association is throughout Europe. You can see here all the members. IBO is one of them. It's an international organization for fostering better, sustainable, better building products. We are convinced that for sustainable construction and living, the materials are very important. It's not only the energy efficiency for heating or cooling or warm water, it's also the materials. Natureplus was founded 20 years ago in 2001, and the members of the Natureplus Association are from all relevant areas of the construction sector. And our core, what we really want to do is help for the people and resource and climate-friendly production. These are the most important concerns of Natureplus. And so we developed the Natureplus label for sustainable and healthy buildings. And this label reflects the holistic approach. Well, developing criteria is a lengthy and detailed process, but it's the only way to find products that meet all different requirements in the best possible way. This fulfillment is then is verified by tests from independent labs and by factory visits. And these assessments are also regularly repeated. And this eco-label guarantees that the product is far above the average and is really sustainable and climate-friendly choice, and this European-wide. So it's not only the label, but it's providing services, it's doing some knowledge transfer and also doing some networks. The Natureplus database. This is really helpful to find products. There are more than 500 certified products to find there. So, and if you want to get involved, you are heartily welcome. But now I'd like to switch over to IBO. Why is IBO engaged here? IBO is doing labeling in building products since the 1980s, and we represent Natureplus from the very beginning on, as we are co-founders of Natureplus. IBO is also doing building physics and building assessments and research. And if you want to know more what we are doing, if you don't know us yet, please visit our internet site, and perhaps you'd like to register for our newsletter. Together with our colleagues around in Europe, we organized the Natureplus event series 2021. We started with the symposium Carbon Capture for Free, with inputs from all over Europe. And there were site visits in Belgium, there were exhibitions and presentations in the Netherlands, and a discussion about the comparison of timber, steel and wood in Great Britain. And today we end this series for this year with the webinar, and I welcome very heartily Mr. Sebastian Spaun. He is CEO of the Association of the Austrian Cement Industry. And also I have here in this webinar Philipp Boogman, an expert in life cycle analysis and environmental product declarations. So today we are talking about the Paris Agreement from 2015 says the global warming shall be limited by 2 degrees Celsius. And to reach this goal, everybody has to do his part, its part, everybody has to contribute. So what will the Austrian cement industry contribute? What is necessary? What is possible? What should be, what can we do? Which data can help us? And this is a question Philipp will show us perhaps to start with, and afterwards Sebastian Spaun will show us how the Austrian cement industry plans to reach these climate goals or the climate neutrality. So now I'm handing over to Philipp. And would be glad if you could start, please, Philipp. We can see your screen. Wonderful.
Yes, so hello, I'm pleased to meet everybody. My name is Philipp Pogman. I'm also from the Institute, Austrian Institute for Healthy and Ecological Buildings. And yes, we are talking about cement and CO2 emissions today. And I like to talk about to show you with this first graphic that that you can see that the contribution of the cement industry to the global burden of greenhouse gases is about 3%, and to this 3% comes a certain amount of this energy part. So finally, what is said is about 6 to 8% of the is coming from the cement industry of the CO2 emissions. And however, the production of cement and concrete not only produces greenhouse gases, but also consumes huge amount of water, leads to a lack of sand resources, and the increasing construction activity seals more and more of our fertile soils. Austria's productive soils, for example, decreased by 39 square kilometers in 2020. This corresponds to about 5,500 soccer fields. So just to give you a feeling about the size. And that happens just in 1 year. So, but the current Natureplus workshop series focuses on climate protection. So we know that the greenhouse gas emissions that we emit today have a very long residence time in the atmosphere. This means that the effects on the climate are correspondingly long-lasting. So despite this, global construction activity and concrete consumption continues to grow unabated. Over the past 30 years, annual production of global cement has risen from 1 billion tons to over 4 billion tons. So as in Austria, the production amount has risen in the last 10 years from 4.3 million tons to 5.2 million tons. So this is one of the major reasons why the cement emissions are becoming a problem. And in knowledge of this background, time is pressing to take actions to reduce emissions. We are really pressed to do something immediately against these emissions. I don't want to be misunderstood, and I don't want to blame the industry alone for this situation. The high emissions are mainly due to the high demand for concrete, and thus due to the growth of the world population and markets. So the industry just tries, of course, to meet this demand. And actually, there are only two ways out of this misery. Either we reduce the demand for concrete, or the demand must be met in a CO2 neutral manner. And I just want to show you another folio which shows you the annual CO2 emissions from cement, and you see what has changed in the last years, that China is the growing market of China produces or needs so much cement and concrete that the emissions are going up very high. And another very interesting folio is how the CO2 emissions grow in Austria. They, in fact, don't really grow over the last years. They are quite steady and stay about 2 million tons per year. So before we start with talking about or listen to Sebastian Spaun, I want to talk about some CO2 terms and definitions. The one is the CO2 equivalence. When we talk about the emissions, we always have it always should be counted as CO2 equivalents. That means CO2 has the main culprit of the greenhouse effect, so it's the leading substance. The effect on climate of all other substances is then accounted compared to this CO2. For example, methane is accounted to be 25 times more effective on the climate effect than CO2, therefore leads in a 25-time higher CO2 equivalent. Some other terms, we should always differ between the biogenic and fossil emissions, because the biogenic emissions, as you all know, is called CO2 neutral, because the plants with the photosynthesis, the plant catch the CO2 from the atmosphere and give oxygen to the atmosphere back, and therefore it's called CO2 neutral. Another important term is the carbon content, which means which is with how much carbon is in the material. And very important is to understand what we understand from CO2 sequestration. Carbon sequestration is the process of capturing and storing atmospheric carbon dioxide. And there we also look at the geologic carbon sequestration, which means, for example, even with cement, that the carbonation of the cement, or recarbonation, that means that the concrete is taking up again CO2 from the atmosphere, or some part of the atmosphere at least. Biologic carbon sequestration would be the photosynthesis. Other important terms are the CO2 capture and storage, called CCS, or the CO2 capture utilization, CCU. Capture and storage is a process for reducing the CO2 emissions from the atmosphere through technical capture at the power plant and permanent storage in underground reservoirs. The problem here is that this capturing and storage and utilization is all very, very expensive. And the technique still is has to be improved a lot to get more successful. And the last term I'm gonna talk about is the carbon offset or climate compensation. I was always very strongly against climate compensation because it's very difficult to control, to check if this compensation is really done correctly. And there are, in the meantime, there are labels who control these compensations, but still it's very difficult to control it, and there a lot of greenwashing is happening, and I was always quite against this compensation, but I have my opinion to that has changed in the last few years, because I think it's very important that we reforestate, that we build new forests, and therefore it's very, very important to consider climate compensation as well. So I'm very pleased to hear from Solutions and discuss the CO2 neutral manner in the Austrian cement industry, and give now over to Sebastian Spaun, and hope to hear from new solutions. Thank you very much. So I will give you the...
Philipp, I have done that already. So
okay. Yeah,
fine, we can see already the slides. Mr. Spaun, once again, welcome here.
Yeah, thank you, Barbara. Thank you, Philipp. I will try to start my presentation now. Can you see the first chart? Is it okay?
Yes, wonderful.
Perfect.
Okay. Yeah, thank you for the kind introduction. Yes, and thank you for the wonderful chart you showed in the beginning, where you see the global greenhouse gas emissions. I like that one. I have a very similar one, and this is important to see that, yes, the cement industry and concrete, we are somehow the elephant in the room when it comes to building materials, that's for sure, and we don't want to hide that. I will today try to show you how we want to become climate neutral, or the way towards zero. And this is a lot to do with circular economy, and we will learn a new circular economy. First of all, I will, let's see, I hope I can, oh no, that was wrong. I hope I can move that. Yes. First of all, a very short, just one chart, how many cement producers are in Austria. You see, there are some in the north and some in the south of the Alps. In between are the Austrian Alps, where we have a lot of limestone and traditional cement plants and clinker burning plants were located where the quarries, where there's a good quality for limestone and clay, what we need to produce cement. So cement is burned out of mostly limestone, a little bit of clay, and then we need a little bit of iron, and that's it. And what we are producing in the kilns, in the so-called preheater kilns, is clinker. Clinker is then ground together with, once again, limestone or fly ash or slag from the production of iron to cement. So clinker is the material, the main constituent in cement, which is directly linked and connected to the CO2 emission of our production. And as Philipp said, two-thirds of our CO2 is coming from the calcination of limestone. We have to get from limestone, from the calcium carbonate, what we need to burn clinker to make clinker and then cement, we need calcium oxide. And the problem is, to get that, we have to heat limestone around 850 degrees in the first stage, and the CO2 goes out of the limestone. So two-thirds of our CO2 is coming from this chemical reaction, and we can't really avoid that. But I will come to that. So once I'm coming back to the CO2 emission, to the global CO2 emission, I really did a lot of studies on that, or I went into a lot of studies, and I'm pretty sure that this 4.5% actually is the number that is linked with the direct emissions of our industry worldwide. The best statistic you get from the Netherlands Environmental Assessment Agency. It's the only one that are doing this calculation every year, and they sum up all the scientific, the same the IPCC uses. And so the last number for 2019 was 57.4 gigatons, so billion tons of CO2, including everything, including the methane, including the F-gases, and including the effects of land use change and deforestation, which I think is important to include, because we are speaking about climate change and how to avoid that. And the cement industry, the emission of the cement industry is 2.2 billion, and so 4.5 is the actual figure. Very often, newspapers and studies only take cement in the relation to CO2, to only one of the climate gases. Look on the chart on the right side. It's coming directly out of the latest assessment report, the 4,000-pager. And when you link the CO2 only to CO2, then we have 5.5% of the CO2 emissions. So these are the numbers. The numbers are high. 2.2 billion tons we have to bring down to zero as fast as possible. There is an interesting comparison of Karen Scrivener, the famous binder professor of the NTFL in Lausanne, of the Flanders University. And it's interesting what she's stating. She's stating that the embodied energy in carbon in concrete isn't as high as often stated compared to other materials, basic materials we are using in our society. The embodied carbon in concrete isn't too high. You see here concrete on the second column, and you see also cement, and then you see many other products. Be careful, it's kilograms CO2 per kilogram, not per cubic meter. But generally, concrete isn't an energy or CO2 intensive product, but we need a lot of this stuff. And this is the reason why the concrete of the world together has a high carbon footprint. But it's not the material, it's the amount we use that material. Yeah. And please, is there a question? No.
Yeah, I have a question. Yeah. I want to question these figures, especially for example for aluminium virgin or for steel virgin. The CO2 figures are much too high. That's not possible. Our figures in LCA show that they are maybe a fifth of the energy consumption. There must be a mistake in the CO2 figures, but they are high. But,
the figures I went in the background data, Karen Scrivener, in this publication. It's coming from the data bank of the University of Bath in UK. So I don't know. The numbers are right, but they are coming out of a data bank. I haven't controlled them it's the chart as Scrivener uses it, and it's the data bank of the University of Bath. Everybody can look in this data, but
no, it doesn't matter.
You're probably completely right. I just want to show when you compare concrete to other materials, you will see that concrete isn't that high, but it doesn't matter. It's just a flashlight. Yeah? So I fully accept what you're saying, Philipp. I know you're an expert in EPD and LCA.
So we have another important input from our guests. We have to take into account that these are figures for kilograms. So
yes, that's what I said. The functional equivalent you're using, for example, when you compare houses, is it's wall or cubic meter or whatever. You are the experts, but this is what I said. It's kilogram. It's kilogram. But I will come back to solving this, and I have another chart which is probably also astounding. If you take food like meat from the cow, like cheese, like bonus, like pig, and you see that 1 kilogram of Austrian meat has a carbon footprint of 14 kilograms CO2. And then it goes down to 1 kilogram of bread, 1 kilogram of normal bread, which is responsible for 1 kilogram of CO2. And then you see carrots, and I don't know what this is, vegetables, we all know that. But if you now put in this chart cement and concrete, you will wonder. You see, Austrian cement is around 500 kilograms per ton, which means 0.5 kilogram per kilogram. And you see where concrete is, with around 80 kilogram per ton, or 0.08. So what I want to say is, Philipp, you said it. When it comes to climate change and to the fight against climate change, we all have also a personal responsibility to eat the right products, to build with the right building materials, to lower our personal footprint of transportation and so on. Climate change needs action in all and every area. And I will speak about my area to be sure. Here, I would like to show you very often when it comes to concrete, timber, steel, bricks, and so on, the discussion is dominated by the question, can't we substitute one building material with another? And I would like to go a little bit in this topic. Left, you see the global production of the last 20 years, from 2000 to 2020, of the main materials in the world, like chemicals, steel, and cement. And Philipp, you said it 100% right. What we see here is the chemicals nearly doubled in the last 20 years. Steel more or less doubled, and cement more than doubled its production, coming from below 2 billion tons, going to, you're right, 4.1, 4.0. So now we are stable because China is built. And between 2000 or 2005 and 2015, China was somehow rebuilt or built. So we see a 2.5 more cement than 20 years ago. By the way, 23 years ago, I started in the cement industry, so it's tremendous. This has nothing to do with Austria. And on the right side, I would like to show you the global production of sawn wood in the same period, in the last 20 years. The data is from the FAO, very precise data. And the reason I would like to show you is that in most of the discussion, people are discussing with me about substitution, if this isn't the solving of the problem. And they say, no, it is not. Because here in gray, you see the global demand of concrete, cementitious material, mainly concrete and a little bit of mortar. And you see that the global demand for concrete is 15.2 billion cubic meters. Here it's cubic meters, which is somewhere around 33 to 35 billion tons of concrete every year. And here in the brown color, you see the total production of sawn wood, stable for the last 20 years, and the wood panels. So not all the sawn wood is made to building materials. I would say 50% or a little more is made to furniture, kitchens, and so on, whatever is made out of wood. And the wood panels, well, they mostly go in furniture. So this picture gives you an impression that cement-based materials, whether European or worldwide, cannot substantially be substituted by other buildings material. And this is the reason why we have to do everything to be as fast as possible to decarbonize this building material. Focusing on substitution alone doesn't help us, I would say, any further. It's good because we have then a strong competition. Who is the best? And we need competition. We all need competition. But if you take decarbonization serious, you should be engaged in decarbonizing our product, which for sure is somehow the CO2 elephant in the building material room. That's for sure.
Can I have here, another remark here? Yes. When you showed the graphic before, we saw that all the cement has doubled in consumption, and
yes.
So I see. I mean, I think it's quite clear that we can't replace the whole construction products with wood. I think that's quite clear. But still, one of the problems is we have to stop this enormous doubling of consumption of the product. I mean, it can't. If we haven't endless resources. We have to stop somewhen at some time the doubling of these numbers.
I fully agree that material. Sorry, I interrupted you. You wanted to finish.
No. I just think because it's an economically spoken, it's always bad to reduce something. It's always bad to stop a development in higher numbers. But here I see, for me, it's clearly we have to stop this elevation of figures, and then still there is not wood, or there is also clay, or there is bricks or whatever. They have to fulfill a small part, but they can replace a small part, and they have to do it. And you shouldn't neglect that.
I think we all agree on that. We all agree on that, and I'm not responsible for Mr. Xi Jinping and his cement ordering in China, and I'm not responsible for the reproduction rate in China, and not of the growing. I think you are right, and I will explain what we can do as cement producers, or as designers, as architects, as civil engineers, as ecologists. I think we should, that's for sure, we have to learn to build with less. Famous Mr. Sobek told us 100%. I'm 100% with you, but please, you can't make me responsible for these lines, these outline lines. We are all, as we are listening here, are responsible for that. We have to be.
I'm just curious about the solutions. I'm curious about the solutions, how to stop this resource consumption, this immense resource consumption.
Exactly. So we have to bring down the resources, and we have to decarbonize. Yes, and And every material has to do that. Every material, building material has to focus on that. Each and every. Because you showed in your first chart very impressively, 1/4 of this red, mostly red chart was green. And this green quarter was due to deforestation worldwide and agriculture. So also these so-called green materials have potential, which they should better focus on, which is often forgotten in the discussions, I see. But let's go on. How to do that? And I would like to show you this chart because it's available, it's public, and then I will show you parts of the Austrian roadmap. This is the European approach of the European cement industry. And you see that 1990, the European cement emissions was around 700, it's in the circle, in the inner circle, 783 kilograms. And here is the European roadmap, how to bring that to zero as fast as possible. And you see on the left side, the approach which we think is reasonable. It's the so-called 5C approach. And that means that we have to do everything to bring down the specific emissions of clinker, the main production of CO2 coming from. We have to optimize our cements, second C. Yeah? We have to optimize the concrete. Yeah? And then, very important, we have to go into construction. Exactly what you said, Philipp. We have to bring down the material efficient and material intensity of our production. Why do we need 20 centimeter thick walls just not to be able to look through sometimes? So we have to go in the design and in the assembling. And then, of course, we need carbon capture in our case, and we need carbonation of concrete. And here you see the European picture. You see the levers. Since 1990, the European cement industry could lower this 783 by 100 kilos. And then you see all the classical levers you can bring down in technical process and industry as we have. But you also see the red bars, the red, between, I don't know, 4 o'clock and 7 o'clock. And you still see that the cement industry needs around 40% captured in our chimneys, in our stacks. We have no other chance. And I will show you now how we see that in Austria. And first I will focus on the levers we have when it comes to the clinker production. Where do we stand in Austria? There are things like energy efficiency or the use of alternative raw materials. Hopefully raw materials where you have less calcium carbonate in and more calcium oxide. But this is difficult. But what I can show you, Austria has one of the highest alternative raw materials amounts in our raw material. You see here, Europe has 3.2% and Austria is already at 14%. For example, we are using close to 1 million tons of construction and demolition waste, also brick meal, in our raw materials to substitute clay, natural clay. So we are one of the biggest users of construction and demolition waste. So let's see, we are making cement out of construction and demolition waste. The right chart, do you have a question?
No. Yes.
Right.
Just the question is is this in the clinker where you replace the raw material in the clinker? Or...
No. The left chart is in the raw material directly instead of clay and limestone. This is okay. the blue line, and on the other side, I show you how the cement is constituted in Austria. We have around 69 to 70% clinker as main constituents, and we are using blast furnace slag, lime, fly ash. Fly ash is going to zero, by the way, because Austria closed its last power plant. I think it's 2 years ago. So we are running out of this coal-based fly ash, and we need gypsum. 70% is quite good, but I will show you. How we want to go further in reducing the clinker in our cement. A second lever for clinker is the fuels we are using to heat the kilns. Here, Austria is outstanding worldwide. We already were above 80. I think this is the year 2019 that we fall a little bit back to 78%. So we could substitute coal, oil, and gas in our kilns with waste fuels, mainly waste fuels, with non-recyclable plastic, with waste tires, with somewhere around 30% biomass content in all these mixtures. And you see Europe is at 50, the world is at 19%. So we are quite good in that. And all these effects together. Now here another chart. So when we are producing cement in Austria, we are using close to 500 kilo to 450 kilograms secondary materials. As Philipp said, we are producing 5.2 million tons cement, and we are using 2.4 million tons of secondary materials. Secondary materials in the raw materials, secondary materials in our cements to substitute clinker, and alternative fuels. As Andreas Hackerl, he is very active, I see, as non-recyclable plastic and so on in our kilns. Plastic that otherwise would have to be burned in waste incinerators, since Austria has I'm very happy about this, a very strict landfill laws. We are not allowed to landfill burnable materials. So Austrian cement industry has one of the very highest secondary material recycling in the process. So close to 500 kilograms per ton of produced cement. And all this together leads to a world-leading position in CO2 efficiency. So the cement in Austria is a little bit above 500 kilograms CO2, which is still a lot, but compared to 1,000 other cement plants in the world, the Global Cement and Concrete Association in London is doing this approach every year. We started it with the World Business Council of Sustainable Development and doing this since, I think, close to 20 years. And Austria is leading, I think now since 6 years, the worldwide ranking. But this shouldn't mean that we did enough. How can we bring this now down, as I said? And here I will focus a little bit on cement, mostly on cement. So what is our path towards neutral? We are right now developing and doing a lot of research for new cements with less clinker in it. The so-called CEM2B, they are nearly rolled out in Austria. They are on the way to be the new main cement coming from the cement 2A. And we are just in the developing and in the procedure with our building authorities to get the CEM2C in the permitting process and then in the market. And the CEM2C and goes down to 50% clinker, and we are also doing already research on the CEM6 cements, which go deeply below 50% clinker. So this is a big lever, of course, because clinker, as I said, holds the emission, the process emissions and the fuel emissions of the kiln. So every percent you bring down the clinker content is really a big lever in decarbonization. And of course, as I said, we used fly ash, for example, and we are using this slag, ground granulated slag from the iron production. And well, since the steel industry is also changing their production systems in the future, and the steel industry is going along their carbon roadmap, we will see other stove technology, we will see hydrogen, direct reduction, and so on. So the slag we traditionally used is changing and is most probably going down in the amount. So we are having a problem. We are running out of this traditional, very good main constituents we had. And so we have to find new ones which are there. And this is calcined clay. Sorry, this is German. Sorry for that. So we are doing a lot of research in our own institute. We are running an institute together with the Technical University, and we are on the way in finding new main constituents and calcined clay. Philipp, you also mentioned clay. We want to take this instead of the stuff we are slowly running out. And we are also doing research in using concrete fines from the recycling of concrete from building materials, because concrete fines, yeah, there's a lot of cement thrown in, and so they are also qualifying to be a new main constituents for cement. So, of course, this is our business in making cement, but it is very hard. Every cement, every percent bringing down the clinker content means, of course, big changes in the manner you use this material. So it needs a lot of research in keeping the performance of the cements high when it comes to compressive strengths and things like that, which are very important for the construction industry, and do all this with less and less clinker. This takes time and takes a lot of research. And when it comes to construction, well, that's not the part of the cement industry, but our industry is very, very convinced that also in construction, there's a big need to go for a completely new design. I stole these wonderful pictures from the famous institute in Stuttgart, ILEC, of this famous architect Sobeck. And more, and it's still in the university, mostly in the university. On the right side, it's the ETH, it's the Nest building, this famous one. The students and the academia is going in this bionic construction, in really optimizing the building materials to just put building materials with the right performance at the right point. And well, I'm very impressed with the next pictures also from the ETH in Zurich. Well, if this would be a traditional concrete ceiling, which is normally, I would say, 20 centimeters thick, and this is 15, here the students at the ETH showed how could we bring this down with the same compressive strength and so on, and you see a construction that has minus 80% materials. I'm not convinced if this means minus 80% cement or clinker, because mostly you need then a very good binder. But the direction is just the right one. We have to show how we can have the same functional unit, which less material and therefore carbon and resource intensity. And we really want to motivate university students, architects, young fellowships to go in this direction. We have no interest at all to not change the very traditional building behaviors. We know that we are working in a sector where the innovation takes a long time, but we know at the same time that this is one of our biggest disadvantages. We have to be faster on that, that's for sure. And then another C is the carbonation. Philipp mentioned it already, that concrete is able to take up CO2 from the atmosphere. On the left side, you see from our lab what typical our laboratory people are testing nearly every day. They are testing the carbonation. So what you see here in white, not in violet, when probably this part of concrete is 50 years old or 30 years old and was drilled out or broken out of some construction site where we were not sure if the quality is still good, and where the color is light, the CO2 was carbonated. So limestone was built from oxide, calcium carbonate was rebuilt. And where it's violet, carbonation hasn't taken place. So you see, it's not 100%, it's somewhere around 20 to 30% the potential in the life cycle of a building. But be aware, when you're at the end of the lifetime of a concrete, then recycle this concrete and you break it to small diameters, like 10 millimeters and so on. Then the air, the normal air of the atmosphere, can carbonate on all its surfaces. And so, there are many numbers in the room, but the most important thing is that we will go in a new recycling of the concrete, where the goal shouldn't be to make it as cheap as possible, where the goal of CO2 uptake should be focused more than it is now, because now it's just only, once again, universities and some startups are really trying to bring this decarbonation up to the highest. But it's a very simple and natural process that can be forced in the recycling phase. In the life phase, nobody can force it. It depends on the quality of the concrete, how fast CO2 goes in the pores and carbonates. So a very good concrete has a low carbonation. A low quality concrete has a high carbonation. Here you can measure this, you can see it, it's very exact. But here I'm coming to another problem, or to the main threat of the production of cement. It's the process emission. It's the emission that comes from the decarbonization of limestone. Here you see the numbers of my industry in Austria since 1997, so for a very long time. And what you can see is the process emission didn't really change. And that's no wonder, because it's chemical. So carbonation is one of the tools we want to bring down this process emission in the lifetime and in the recycling. And of course, this is only around 20, 25, probably 30%. And one thing is important, in the sixth assessment report of the IPCC, which came out this August, which is terrible to read. The first 50 pages is enough to really get a dramatic picture of the situation of the world. All the numbers are much higher and much faster than it was in the last assessment report. So I hope all the politicians now for Glasgow read this first 50 pages. This is enough to understand how dramatic the situation is. But when it comes to carbonation, I'm happy that first time the IPCC fully takes recognition of this concrete sink or cement carbonation thing, and from now on this will be official accounting will take place on IPCC on this effect. But now I will come to this Austrian roadmap, which is still a draft. We are ready with the calculations, but we haven't published our roadmap. But just to show you, I'm sorry, it's German. On the left side, you see 100% of our emission, which sums up to 2.8 billion tons, million tons. And then you see the levers. You see what we think we can make in these different levers, what we can make in the clinker production, what we can make in light green, in lowering the clinker content in cement. How much is the power of decarbonizing the electricity we need for grinding the cement and running our companies and running our industry? It's not a lot of potential, because Austria already has a very green, or kind of green electricity. And also transport doesn't play a major role when you look to the production of 1 ton of cement. Then you see the potential of carbonation of concrete. Yes, there is a certain potential. Yes, we have to really bring this out, that recycling could be and will be made in a different way in future to maximize this carbonation effect. Yeah, but in violet, then you see that we, in the cement industry, we need this carbon capture. And of course, when you then capture the CO2, which is very expensive, as Philipp said, what to do then with the CO2? And I will show you that what we are running here. Austria, I just read it somewhere in the chat. In Austria, we have a law that forbids sequestration of CO2. We are allowed to sequester it for a certain time. Yeah, German word Zwischenspeicherung is allowed, but we are not allowed to sequester it in oil and gas fields, or also in the earth crust, also not in the stones. But well, this law is now 10 years old, and let's see what the future brings. The situation is completely different in all the member states around the North Sea. In the North Sea, Norway, Sweden, Denmark, Germany, UK, and Netherlands are really planning, let's say, a full sequestration for the industry around the North Sea. We are seeing already prices, we are seeing pipelines being built, and we are seeing that the first cement plants around the North Sea will come into operation with sequestration in the year 2024 to 2025. And we will also see the first chemical industries fully decarbonized with sequestration in the North Sea in the next 5 years. So this is a lot of competition for Austria, for our country, and for the industry here, because in the North Sea, the sequestration of CO2 is somehow state organized from the member states. And so we have to go another route here. And the route I can show you a pilot project is the so-called project Carbon to Product Austria. It's after 2 years of funding and so on, this project is getting more and more visible. And here you see the Lafarge plant of Mannersdorf on the left side, the biggest plant in Austria, and which will capture first in a pilot, but until 2030, they want to capture the full CO2 of this biggest cement plant, which is 700,000 tons per year emission. And then the Verbund, the biggest electricity companies, would bring in the renewable energy and make hydrogen out of that. And together with the CO2 of the cement plants, this would further go in the refinery process, and then in the next step, polymerization in the biggest plastic producer in Europe, Borealis, which Borealis is making close to around 1 million tons of plastic, new materials. And this is for us a very interesting situation, having very close to this refinery and this big polymerization plant, having our biggest cement plant with 20 kilometers of pipeline. We could really solve this. Yes, I see the topic of e-fuels. I mean, the focus of the project is plastics and probably in future also chemicals. So making plastic not out of raw oil anymore, or making chemicals out of gas, fossil gas anymore. Instead, making the future plastic out of CO2, which cannot be avoided with other tools, for example, renewable energy, hydrogen in our kilns, or synthesis gas in our kilns. So for the CO2, we have no other option to make this as new feedstock for materials. The pilot plant is I would say, good underway. We'll get the information from the EU Innovation Fund, and is also part of the IPCEI hydrogen. The consortium is very positive to get green light, but it is expensive. The pilot plan for 10,000 tons will cost 120 million euros. But we need these pilots to really be able to figure out if the technical process work well, and then to begin the upscaling, because from 10,000 tons to 700,000, you can imagine a lot of cost and energy is needed. Well, I skipped this chart because it's German. Once again, it's a very interesting and powerful consortium. It's the market leader of each and everything, the market leader of plastic, the market leader of refinery, of electricity, and of also in Austria be the market leader of cement. But the whole cement sector is supporting this project, because the small cement company wouldn't really be able to go in an investment of a pilot of 100 million. So we are all very happy that, and we are really positive and hopeful that we get this pilot on the ground in Austria. You can imagine that in Europe and worldwide, there is a lot of competition with getting this first completely new technology on the ground. And what I said in my title was, are we speaking about a new circular economy? We think yes. Also, the utilization and the use of CO2 as a new feedstock is, of course, at the center of this project. We can also show a new circle for carbon, which means we would burn this non-recyclable plastic of the future. And when you speak with top experts of the plastic industry, they will tell you that more than 50% of mechanical and chemical recycling is not seriously possible or is not seen in the future. So there will always remain a waste rest, and we think it's quite a positive thing to burn this rest in our kilns, because we need that energy to produce clinker, then capture it so that no carbon will see the atmosphere, and then bring this CO2 with hydrogen together as new feedstock in the growing demand of plastic. You saw that plastic is also in future the most growing material in the world. I think it will not be cement anymore. It will be, for very many reasons, it will be hydrocarbon and chemicals. And well, we could therefore close a loop. We cannot bring away this carbon, but we can show that we can keep carbon in a cycle. And to be very honest, of course, we are bringing in also carbon from the limestone. As I said, 2/3, that's for sure, but it is probably a second effect to have plastic not in the atmosphere, not in the ocean, but in a circle that can be completely renewed, because we bring it down to the molecular area. So I'm coming to my last chart and to the conclusions. I wanted to show you how this decarbonization roadmap will work, and we are fully committed to the figures we will bring in the public in the next 2 months. So CO2 reduction, clinker production, including the development and upscaling of carbon capture and storage and utilization, is for sure, when we bring this project to the ground, one of the main levers we have. Then, of course, the optimization and lowering of the clinker component in the new cements, in the composite cements, with the CEM 2C and CEM 6 cements. We have to find new materials for that, because we are running out of the secondary materials of other industries. We will have to go for a very targeted selection of concrete types with low CO2 emission in the planning phase. As I showed you, we will have to focus to really optimize each and every building part in a building to best use the manners and the strengths and the functions of a material. So a completely new design and yeah, also a big step in the construction industry, probably with spin and digitalization, it will be easier. We will have to learn to construct our buildings much more efficient. And this is valid for all the building materials, because I see not too many differences right now. If I look also to other building materials, we are building like we did it centuries and decades before. And we have to make our structures, our infrastructure more durable. We have to use our railway tracks, our streets longer than we did it before. So at the same time, we lower the carbon, we have to higher the durability. And of course, absorption of CO2 in the concrete, and especially in the recycling phase, will become a bigger and bigger topic. To optimize this to a certain extent, we are very realistic. Recarbonation can only solve a smaller part of the problem, but it can help. Thank you very much, and I would be very happy to answer all the questions which I couldn't focus during my presentation. Thank you.
Thank you, Sebastian. I didn't interrupt you because I thought it was very interesting to follow you. So, but I still have
Sure.
one or two questions from my side, and then I think we would open the platform for everybody to ask questions if you agree. And my first question is to the use of alternative fuels. You said it's about 78% in Austria, and these are very impressive figures. But I dare question the conclusion, because Austria burns more municipal waste in cement plants than other countries. Isn't that correct? I mean, for example, in Germany, they also burn car tires and use the energy, just not in cement plants, for some other industry parts. So isn't it somehow a bit of a delusion that Austria is so very good in using alternative fuels? I think other countries use them as well, but just not for the cement industry.
No, I would say, if you look how much amount of waste is burned in Austria, we are using around 500,000 tons in the cement plants. But the incinerators in Austria, we are very, as you know, we have a very developed waste management systems, one of the best in the world, I would say. So we are using at least five times more waste in the incinerator. So we're using around 2.2 and 2.5 million tons in the waste incinerators. So municipal solid waste, we are not using directly municipal solid waste. We are using other types of waste coming from mechanical pre-treatment and so on. But and then we have also the use in the paper industry. So we have another amount in the industry. I think together this sums up to somewhere around 4 or 5 million tons. So you see, if you really phase out landfills in a country, then you can't do the job with the cement industry alone. You need incinerators, you need other industries, and you need the cement industry. You need any and every capacity, I would say. But as you know, I think only 7 countries in Europe are really burning their burnable waste. Most others are still very landfill-based, which doesn't make any sense when it comes to climate change and leachate and wastewater. But to be honest, yes, we are very good in that, because we have a very close cooperation with our ministries, with the environmental ministry. We have very strict input limits for and output limits for cement, input limits for all the alternative materials. And so it's trusted in the Austrian way. There's a lot of trust in it, and that has something to do that we have this high rate. So limits, as a tight legal network, strict limits also when it comes to the emissions. So, well, it has something to do with legal certainty in Austria. Did I answer your question?
Yes, yes, of course. But isn't it so that the municipal incineration has more strict regulations about the emissions than a cement plant has? I mean, we know in the past we had some problems with burning emissions in cement plants, but
well, I don't want to go in this. I don't want to go in this detail. Of course, yes, it's known in Austria, but not European. But we had a problem in the cement plant, but we exactly know the technical reason. There is a reason why this happened. There was the wrong material at the wrong point, and the emission couldn't be avoided. But I think we did it in a very open and very fair way together with the authorities to clean that up. So I would say we know exactly what we are doing, but of course we also had a problem which was a big disaster. But this is not true. I mean, you have to see it in that way. We are under the same law, and yes, you're right. The limits are different. For many pollutants, they have stricter limits, but on the other side, you have to see when we burn coal, we would have nearly the same emission when it comes to, for example, to nitrogen. We would have even higher emissions. So this is something to do that industry are producing, and when they use waste, then they get stricter limits as when they use primary fuels. So I would say there is nearly no extra emission when we use waste, because we are getting, together with the waste, we have to fulfill stricter limits. When we burn coals, we would have had higher limits. So there is no surplus emission.
Okay, yeah, thank you. I have two last questions to another subject. The one point is we didn't, or you didn't really talk about, is that a big lever is certainly in future dismantleability and reuse in the same function of concrete products, and or in other building products like wood. I think there is a huge potential, and circular economy becomes more and more important. And I think somehow my feeling is that it starts that we are starting very slowly in this process, and I think it has something to do with the economy, because no industry is interested in longer life terms of their products, because they want to sell their products. So I think sometimes do you see that as a problem as well, or how do you see?
You are right. Dismantling and using ceilings or parts of the ceiling or tiles and so on. Well, this is simply no business case, and we have together we can analyze why this is no business case. Yes, industry needs to have a business case to develop then a new way of thinking. I wouldn't say that. And on this is the one side. On the other side, we are having a product, concrete, or we are producing a product that can be recycled very simply and to very high rates. So if you take out, or you get product out of very clean out of a building, this is important. Then the recycling of concrete is well known, is done to 90 to 95%, and this product has a positive value. So it's really used. So in dismantling and using building parts, this is, we have no experience, and you know, once again, you then need the full value chain. You need the architect, the builders, the constructors to use these materials, to trust in an old building material. Yes. So you need, of course, you would need a lot of new static dimensioning processes. So you need a lot of people, as we need for new buildings, to make this old but usable material a new one. And so it's easy for me as cement industry to say, well, you're 100% right, I would like to see that, but it needs a lot of other professions in the value chain to give green light, The planner, the new architect, the static, responsible for each and everything. Yes, you are right, it would be a big help, but it's not done yet, and I don't see it also in other materials. Except the old bricks from Maria Theresia, when we do our gardening, then we use them.
Yeah, I think it's just a real task for politicians as well to set up more law rules for circular economy. And the last question I have, do you really think it's feasible? I always think it's very interesting to hear the year 2050 to be CO neutral. Do you really think it's feasible for the whole cement industry? When you look, I know you're not responsible for China, but when I hear the projects in Austria, you talked about the Lafarge of the CO2 pad, and I think that's just one project in Austria. And what about the other eight plants?
You are right. Look, the speed of the innovation, the growing of projects is so fast that I personally, and to be very honest, I have the feeling now in my sector that I am sitting in a high-speed train that is running at around 300 km/h. And this is what I see in the moment. I can explain you that. Lafarge had 2 years ago 5 projects of the one I showed you worldwide. Lafarge has 250 plants, I learned, in the world, and 50 in Europe, and they had 5 projects, 2 in North America and 3 around Europe. And one is the one I showed you. 5 projects 2 years ago. In the meantime, Lafarge has 15 products plus 15 in Europe. Not in this dimension, but in a similar dimension. So you see, the speed is taken up. The industry really, let's say, is committed and convinced that we have to find a solution. And trust me, the Chinese are not the slowest ones in the world. If the big boss says we have to do something, and so I'm personally I fear one thing. What is when in 2 years from now in Rotterdam some big vessels come with CO2-free cement to Europe? I'm very sure and I'm very convinced that this cement will find a construction company very fast. And believe me, I personally think that this pressure that's coming also from other continents is one of the reasons why Europe is now really pushing. We would not like to see that the first CO2-free cement is developed in China. We would really like to see to have it in Austria or in the neighbor countries and other countries, of course. Let's be not too optimistic. So, Philipp, to be honest, what we need for this technology I just showed you is we need for the hydrogen, not only we don't need the hydrogen, but plastic then would need the hydrogen as new feedstock. Steel would need the hydrogen, and we probably a little bit for our kilns, yeah. But I'm pretty convinced that we will keep on that waste, yeah, as long as it's there. But the problem we all have is that all this decarbonation of the big materials of the work needs electricity, green electricity. And as you know, Austria wants to be 100% neutral in 2030. And we all know that means that we need another, let's say, 8,000 windmills, and we need photovoltaic in an area as big as Vienna. And when you want to have the permit and the environmental assessment for such wonderful things, for the renewable energy, it takes you in the moment still 8 years, 10 years to get the permit for one wind park or to get it for a big, huge. So we are somehow in a panic that we probably will be able to finance the pilots and then probably be able to upscale this plant for Mannersdorf. But what is when we have then the plant in 2030 ready and we don't have the hydrogen and we don't have the renewable energy and we don't have the networks and we don't. Can you imagine? Then a company is dead. So in the meantime, we are really talking to the politicians on the highest level and say, we are in a hurry, we have to begin with pilots, we have then to upscale, but you have to show us that you are together able to get the hydrogen done. And this can't be made by Austria or by Germany alone or by Switzerland. We all are aware that the hydrogen we need for this future has to be produced by 70 to 80% in the countries where it's produced cheapest possible renewable. And this means this is probably Romania, Spain, Bulgaria, Egypt, North Africa, for example. And for me personally, it is a very let's say, it's a good future that we would pay in future the oil money of today to North Africa, and the people there are producing via photovoltaic and solar energy the hydrogen for our energy demand, for our decarbonation of our society. This would help us, I think, in Europe in many cases, and it would help the population there. So to be very honest, we need close cooperation of the member states in the EU. I don't see it yet. Everybody thinks that he can live alone and solve the problem in his member state. This is not true at all. We can't solve anything alone. So yes, we need a lot of infrastructure and a lot of renewable energy to get this thing done. But to be honest, we see no other possibility in the moment. If somebody has a possibility now for 50% of our material, then he is highly welcome. If somebody knows how to make clinker without calcium or without carbonation process, he is highly welcome. In the last 23 years, I saw at least 15 highly promoted and also in the academic media promoted alternatives to cement, green cements all over the world. They were developed, but to be honest, not one of them really could be more than 1% market, some niche product and so on. So we wouldn't do that. We wouldn't go this direction, which you saw is very demanding, which is very expensive, which needs a lot of collaboration between industry that never work together. We never work together with the chemical industry. We never work together with the biggest electricity companies. We never work together with a refinery. Yeah, as customers probably. And yeah, but this is the new future, working together across borders, across sectors. And as many of you are coming out of the building sectors, you all know this is the only way to bring good projects on the ground.
Yes, thank you very much. I'm happy that you sound still optimistic, and I would open now the discussion for everybody. Are there any other questions?
Sorry, I was too loud. Oh, it's my English. Nobody understands the word.
So, Tillmann, you want to talk? Because there were some other people. It's namely Andreas Ackerl, and it's also Mr. Anthony Coleman, who had some critical remarks. Perhaps.
Maybe in the chat questions that I couldn't see yet.
Yeah, there were many questions.
But here's Andreas Ackerl. Probably he can ask me his most important questions. You were so active. Please go on.
Mr. Spaun, many thanks. I only did some remarks to it's a complicating issue for your company and complicating issue for all of us, not even in Austria. And I only did some remarks, not more. I have no questions. And I'm a little bit in the item of circular economy because we're training this item and see to better know a little bit. And yeah, no, only remarks, no more questions from my side.
Well, I see your questions yet. Burning biomass, yes, we would like to hire the biomass rate. To be honest, we are not having enough material for that, not in Austria and not in Europe. I think it would be no good idea to switch cement kilns to wood burning.
No, I'm suggesting the opposite, which is in fact the biomass has much more valuable use for other materials, particularly, for instance, for clothing. I know a lot of the pulp mills are actually move to cellulose production for clothing. I wanted to challenge the idea that biomass should be the key to producing renewable energy. Biomass is sequestrated carbon that, frankly, at the very last point should be burnt. At the very first point should be reused. And I'd like to suggest that the Austrian government should rethink its policy on burning biomass and seeing it as a major source of renewable energy.
Well, I think this is an ongoing and a very difficult discussion in Europe. We are right now discussing the forest strategy and parallel the biodiversity strategy. And if you look to the global figures, you see the drawbacks of this main rush to the burnings. We are losing sequestration potential of our forests worldwide. And yeah, you're right. For all materials, we need a better and more valued use of the quality a material has, of the strengths of concrete. You should use that strengths and not just build with concrete. You should use the celluloses faser, I don't know the English word, as fiber. Yes, you should go more in a technical, scientific, developed use of materials. We are using them still too primitive. We are using them just to make a wall or make something. I think this is the new material efficiency and this new resource efficiency. We have to educate the young generations and to look in a different.
What we're trying to do for COP26, to see the nature-based solution thread of COP26 is about using things like timber or bamboo outside Europe as a building material that would reduce the need for concrete, reduce the need for steel, which are huge carbon emitters. While I accept there is a residual need for concrete, surely the key is to have a holistic view of how buildings should be created going forward, which is totally on the basis of minimizing the carbon from the whole of the built environment.
In principle, you are right, but I tried to show these figures in the beginning of my presentation, and there you see that the trees are growing towards the sky, but not in the sky. We see that the whole system.
That's because a lot of it's burnt. It's crazy.
Yeah, probably you are right, but well, I don't want to. I'm not allowed to speak about wood, but with all these positive news, biomass for sure has. One thing is very often not seen, that this makes, in the first stage, it makes a lot of pressure on existing, easy to cut woods. And we are not going in bamboo. We are writing a lot about bamboo, but we are not going in this direction. And I know, Mr.
But we're working with other products like flax. We are growing our materials. Major motor car companies in the UK are moving out of using steel and oil-based plastics into using bioplastics. A lot of those bioplastics are coming out of cellulose and flax and other grown materials. We really need to think about how we are going to move to reduce the amount of cement in the future that is produced wherever possible. And the idea within a circular economy for cement, that there is a role for what I'd call oil-based plastics that have to be burnt, rather than, if you like, bioplastics that ultimately can simply be used as compost, surely is the way forward to actually, in that way, improve soil health and carbon sequestration in the soil. There is a need for a holistic view of how building materials, both for buildings and for consumer goods, should move forward. I know I'm way beyond the cement industry, but the cement industry is part of the linkage on how we view the future.
Yes, but the holistic view is, you 100%, I would say that, but all these ideas and all these wonderful scientific approaches needs a very critical look to the sources. And please also focus on the sources, but because
we are at Cambridge, we are.
Right, but because 12.5% of the global carbon is because of deforestation. This is 2 times more than cement. And there are reasons. It has a lot to do with our food, and it has a lot to do with Brazil and so on. But it has also a lot to do with situations in developed countries and so on, where the pellets going to the tracks in the UK, they're all coming from South Carolina and so on. So, I mean, responsible sources
come to a point where they get to maturity and they rot and they become methane. When they are mature trees, use them. When they are sequestrating carbon, don't cut them down. That is the key.
This is
so thank you very much. I think
not for here, I think. Yeah, not for. It's not my material. I'm not allowed to speak.
So we have a lot of interesting approaches, and thank you very much for talking about the holistic approaches, because that is what we need. I think we had some inspirations. It is really necessary. Everybody, everywhere is doing something. And I thank you all very much for talking tonight about this theme. And yes, Tilman, you want to make some closing words? Or shall I say goodbye all to you? I'm happy to hear again from you and wish you a nice evening.
Thank you.
Yeah, thank you very much
for the invitation. Have a nice evening.
Thank you very much. But I have a last question.
Thomas.
Okay, Thomas, we are listening to you.
Thank you very much for your very interesting presentation. I think I appreciate very much your clarity in your presentation about the cement and the industry of passive industry. And I have one question or 2 questions, perhaps. The first question, because I think it's very important that you can differentiate your presentation about the CO2 neutrality of clinker and also other products of the cement industry. I think it's very important that in your presentation page 22 to 24 that we need your figures about the best case, about the worst case, what is possible for cement industry about CO2 capture and the other measures you mentioned. I think it's very important to know it, because I think that a lot of measures up to date are related to the next years, and not only to 2030, 2050, and the neutral CO2 emissions. And I think that would be a very big import, and also very yes, not the name, but a very big amount to bring this concrete data for the next years to the discussion, to all the scientific institutions, and etc. Okay, I hope that was quite concrete, but I think the important point is that we need a detailed version of your scenarios for 2020 to 2040 for each year, and for the worst and for the best and the worst scenario. Sorry for my English. Okay.
No. It's the same as mine. So I understand everything. Understood everything. Well, we will, in our roadmap, which we will publish, you will see steps like 2030, probably 2030. You will not see 2025. But to answer you the question, what we are doing, we already started 2 years ago, is this project to get new cements in the market with a lower clinker content. And we will try to finish this in 2040. We hope that we then are at 50%. I mean, I can make a linear line, and I can make, some steps. We are starting now, and in the best case, we have to bring it down every year by 2% or 3%. This would be the best case, because it needs time to get them in the market and to get all the construction companies to get used to that materials and so on. But when we look to the product, this is let's say from now, from 70% clinker to 2040 to 50, you can make it linear, or you can make it in steps. This is the one thing. When it comes to these breakthrough technologies, I try to explain. We want to be as fast as possible to have this pilot plant, and probably a second project is appearing in the cluster of Voestalpine of Linz. There's a second similar cluster appearing with many universities on board, and which is clear that this is the second cluster. But to tell you the truth, when everything runs fine, we will have the first 10,000 tons of carbon-free cement in 2025. This is best case. Only 10,000 tons from 5 million. But it would be wonderful to show that this is possible. And if the pilot plans, if the decisions are made in the next, let's say, 5 months, we get positive feedback, or Lafarge and the consortium, then this would be possible to have the first let's see, 5 buildings, social housing buildings with CO2-free concrete. But then we will run this pilot plant, and then we have to be sure that somebody buys this, of course, much more expensive cement, also for the pilots. I'm optimistic that we will find customers for CO2-free cement. And then, well, it could be 29 to 30, 31 to have 25% of the emissions then captured, but we don't know yet if we will have the hydrogen and if we will have the electricity. You know, we can't really control this factor. If the society, if the infrastructure will be able to make this huge transition, which means that it's not only to be neutral, because at least the transformation process of our industry will not only double the electricity demand for cement production, it will triple it. So to make finer cements, to bring the clinker content down, to run capture plants, which you need a lot of flue gas cleaning, extra, and so on, and to bring in hydrogen in new burners or synthesis gases, we know that we will not use 100 kilowatt hours per ton of cement, we will need them 300. This is not very much because cement doesn't need a lot of electricity, but it is also for our small meat, it means factor 3. And when you go to other industries, it is probably more than that. So this is a condition we can't control by our own. We want to be as fast as possible to show how it could work, and then we would also, and the reason, once again, the reason, and then I finish. The reason is, as you know, we are running out of certificates of the emission trading system in Europe, and you probably wrote in the newspaper the 55 package. From 26 on, from 25 on, they will take away 10% per year of free allocation. 10% per year, the price today is 60 euro. So if you bring this down, we are not getting free allocation certificates, we are at 0 at 35. So to be honest, if you multiply this amount of CO2 with 60, probably 100 euros, we see that not 2050 is the date that is relevant for our industry. We see that we better try to be ready by 30 to 35, which is unrealistic because we will not have the hydrogen and we will not have the electricity, I suppose. But the cement price will probably have to be doubled in this year until 30, 35 when we have to go this direction. And as you know, in Turkey alone, we have around 40 to 50 million tons of overcapacity. Austrian cement production is 5 million tons. So we are having also a distortion problem. Is Europe able to really transform the European industry and at the same time avoid that we are substituted not by biomass or any other material, that we are substituted by not decarbonized clinker from other areas close to Europe? So we have 70 million tons of, this is
no, okay.
I try to explain that it's not in our hand alone.
Yes, I understand that, but okay, thank you very much for your detailed answer. And I think we trust in you and your colleagues to carbonize cement in Austria. And I think in 1-2 years, we will discuss together about the first success. Thank you very much.
Press your thumbs, because I would like to have it in Austria and not in US or in China this first.
Yes. Okay. Okay. Thank you.
Okay, anybody else who has some really questions? Because I think
We are late.
we have done for
Yeah,
tonight.
already.
Oh?
So, sorry, final question. Will the presentation be available?
Yes, I will send it. Already sent it. Let me just go through once again. There were some still German parts. I will try to get this in English because it's unfair to the others. And probably I can send you that tomorrow. Barbara Bauer and you, as you will. Yeah, it's
Perfect.
of course
Many
you
thanks.
can have
Okay.
it. Yeah.
Thanks. Interesting, Mr. Spaun.
No,
Good luck.
welcome. Thank you.
Thank you very much, yeah, to all.
Okay, so we are finished.
Okay, thank you very much.
Yeah.
I'm
Bye-bye.
leaving now.
Sebastian,
Have a nice evening.
Tilman wants to say
Thank
one
you.
more word. Okay,
yeah.
last.
Sorry.
Tilman?
No, just many thanks, Mr. Spaun. I think we could discuss a lot more about that. Also, like the steps we could undertake now and so on, and also other things like sand and so on. But yes, thank you so much.
So thank you very much, Mr.
Maybe
Spaun.
there could
Thank
be
you,
another
Philipp.
possibility another time.
Also from my side, have a nice evening. Thank you very much. We will discuss further.
Have a nice evening. Bye-bye.
Interesting.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.